Hey everyone, this is Dr. Walker. This is video 562 called Household Wiring and Electrical Safety. In this video, I just wanted to make a few interesting notes about things that you can probably relate to that apply to your home. So the first thing is about household wiring. We receive power from the utility company and it distributes the power with a pair of wires. One of them is going to be live at 120 volts and the other one neutral, which is grounded, so it's at 0 volts. So that means that the voltage that we get from the utility company, the potential difference between those wires is about 120 volts. And then what happens is that's going to be connected to different circuits, and there will be a circuit breaker just to make sure that there's not too much current flowing. I don't know if that has maybe happened to you in your home, but it used to happen in my home all the time. I used to have the toaster oven on at the same time as the microwave, and it would blow a fuse. We didn't have circuit breakers in that home. And so what happens is, let's say you got 3 devices that are hooked up, and they're each going to draw some current depending on the power rating of that appliance. So let's say you have, toaster oven drawing, let's see if I can have a reasonable number here, drawing maybe about 8 amps. Let's say that it's about 1,000 watts, and you get 120 volts, then you get about 8.3 amps. So you have a microwave that's 1,300 watts. That would give you about 10.8 amps here. And then let's say you have a coffee maker, about 800 watts, and that's about 6.7 amps. This one here was about 8.3 amps. So you know that when you're in parallel that the currents add, so that means that you're trying to get 25.8 amps here. So if the circuit breaker is not designed to handle that much current, then you'll be tripping that circuit breaker. So that's meant to protect our homes, and so we have different devices connected in different circuits so that they don't have to draw too much current. Another thing I wanted to mention, if you've ever seen this weird looking plug, right? So maybe for your washing machine. So some appliances require more than 120 volts, so maybe 240 volts. So these plugs, they have an extra line that is at 120 volts below ground. So that allows us to have a potential difference here of 240 volts. So in case you were ever wondering what that extra third plug was, that third prong. And then another thing is short circuit, and I know I just mentioned in a previous video, forgetting that it was going to be mentioned in this video, but so short circuit is when there's almost zero resistance between 2 points at a different potential. When you have very little resistance, you're going to have a very large current. So let's say this person is holding this drill and there's a frayed cord, and so the body is going to provide the path of least resistance, and the person is going to feel a shock, and it can be very, very dangerous. So that's why a lot of appliances have this 3-pronged power cord. I'm sure you've seen these. So in case you're ever wondering what these were, these do not provide 240 volts like the previous ones we just saw, but these ones have a safety ground wire, which would be this green wire here, so that if something does get shorted here, then the path of least resistance is going to be safely through this safety ground wire so that the person does not get shocked if something like this happens. The next thing I wanted to mention is, well, what's the result of electric shock? How much current do you actually feel? So results of shock vary greatly. It depends the amount of current, how long that it's going through your body, which parts of your body it's going through. It can cause burns and cause muscles to malfunction. It just really depends on a lot on how much the current is. So you need 1 milliamp. This is in milliamps here, this current. So 1 milliamp is when you can start to feel it. But then it it jumps really quickly. So by the time, if you have a current of 10 milliamps, let's say going through your arm and hand, then sometimes you're not even to let go of that wire because it prohibits your muscles from moving. So once you get up to even 50 milliamps, it can possibly be fatal. Again, it depends on the body part that it goes through. So 100 milliamps is already very dangerous. So you may be thinking, oh, well, that doesn't seem like a lot of current. It doesn't seem that it doesn't seem like current is that dangerous, but the human body can have a lot of resistance. There's a huge range. It's approximately the resistance. This is an approximate number from like 1,000 ohms to 10,000 ohms. Depending on if it's wet, there's less resistance. That's why you never want to be wet when you're touching your circuits because there's less resistance. When you're dry, there's more resistance. So let's say that you have 120 volt outlets. Well, if you divide by 10,000, that's going to be, let's see, so you divide by 10 and then so you have 0.012 amps, right? So that is 12 milliamps. So that can already be pretty painful. But if you're wet, right, then all of a sudden it's already 120 milliamps, which can be fatal. So just be careful when you are handling electrical circuits. Make sure that you have maybe, rubber soles. If you have rubber soles, which is a good insulator, then your body's not going to be the path of least resistance a lot of times, and that helps protect you as well. The last thing I wanted to mention is, just in case you were wondering what these were, that you see them usually in the bathroom. So these are ground fault circuit interrupters, the FGCIs, and they're designed to help protect people from electric shock. And what happens if it detects a lot of current, then it's going to shut off really, really quickly. So it's just designed to help protect you from electric shock by acting like a fuse or circuit breaker and shutting off that circuit really, really quickly. So that was it, just a little bit of information, just conceptual things to help you appreciate the devices and electronics around your house just a little bit more.